Welcome to today's webinar. The topic today is most frequently asked questions answered by Dlubal support team, our regularly webinar. For the attendees who participate the first time in the Dlubal webinar, I would like to introduce myself. I'm Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the content of the website, the German and English webinars, customer projects, newsletters, and so on. I will be the moderator today and also the presenter. I will be supported by my colleague, Jürgen Teilmann. Jürgen, you can introduce yourself.
Yes, thank you, Andreas. Yes, my name is Jürgen Teilmann. I work for Dlubal Software, mainly in customer support, which means I will answer all your questions, may it be via phone, via email, or via our website requests. And today I will be doing exactly this, answering your questions. So Andreas will tell you where to direct your questions in the panel to us. And with these words, back to Andreas.
Okay, thank you, Jürgen. Then we can switch off our webcam so the attendees can see the full screen. Some words, how you can ask questions via the control panel on the right side of your screen. You can show that with that arrow, and then you can enter your question here. You can also watch the entire webinar and then email your questions to info@dlubal.com. Okay, then let's turn to RFEM, an empty model. And the first question is, how can I export or import an IFC file in RFEM6 or RSTAB 9? You can do that via File, then Export. You can see IFC and the other interfaces, then Import. Also IFC and the other interfaces. The version 4 is supported for import and export, and the older version 2x3 only works when importing. And regardless of which direction you exchange data, the structural analysis view and the reference view, also the coordination view, can be processed. So let's import an IFC file. So that file. You can choose any coordinates where you would like to import it. So, and then let's press OK. And you see the import was good, but you can see the direction of the Z-axis was an opposite direction in the CAD model. That's why we do the import again. File, import, IFC. So, and we mirror the Z-axis. Okay, that looks quite better. Imagine we have to design the steel construction. We ignore the building here, the concrete structure, and let's prepare the model for the design. You can see at the moment it's only an IFC model object. We have to check the CAD BIM, the conversion tables. The steel material has to be assigned with the material from the database in RFEM6. Also the sections, you can see the different cross sections. The most of them I already assigned, where I assigned already the correct RFEM section from the library. The concrete items are not from interest for us in this example. Let's assign the AGA 160 from the CAD program. That's a standardized profile. So, and then AGA 160. Okay, now the list is complete. So, and what we have to do now, we have to select all, and then with a right click, we convert into straight members, the whole construction. Okay, let's disable the other IFC objects. Now, here in the navigator IFC on the left side. Now there's only the steel construction. Yeah, that looks quite good, but only in the transparent or solid model. But when we take a closer look in the wireframe model, you can see the members are not connected to each other. Let's turn back to the solid model. In the CAD model, the horizontal beam here is connected with the flange of the column, and so on. But we need the axis of the members, and they need to be connected. So let's turn back to the wireframe model. There's a function in RFEM6 how you can correct such things. I select all, and with a right click, I can modify the members with the feature extend trim member. Okay, let's do that. We would like to extend them to the next member or line on both sides. Okay, that looks already quite good, at least at this node and the other nodes. But you can see the purlins are not yet connected because we have an offset, but we will correct it. But in that case, also for the bracings here, we have to do that manually. For example, with drag and drop. So here the same. Also on this side. Okay. So, and now we come to the purlins. I use this function that we connect the members or divide them with a node that I can, for example, delete such a member. But in the first step, we move the roof members to this node with the move copy function. So with a vector from this node to this node. Okay. So let's turn to the -y view. So I delete these parts of the columns. Okay. Also this one. Okay. So, and now I need to extend the purlins. I select them. Then with a right click, I turn to the already showed feature, extend trim member to next member line on both sides. Okay, that looks already quite good. In the first step, I would like to change the bracings here from, with a double click, for example, from beam to truss. So, and I change the purlins or I add hinges. So double click, hinges, go to the table hinges and create new hinges around the Y and Z axis of the member. Typical moment hinge on both sides. Okay. Yeah. Then we need to add supports. So I add supports here left above. So nodal support in all directions and around the Z axis. Okay. Okay. And the columns are supported now. And we create also supports on the concrete wall here. So new nodal support in all directions and around the y-axis. Okay. Yeah, that should be all. The model is now corrected or modified. We can go to the tools and do a plausibility check. All is okay. And let's calculate the self-weight load case. Okay, we get results. That means all is connected correctly. And the model can be, we can assign other loads, snow and so on, and wind, and calculate the structure. Now you can see, it's quite complex to modify such an important model. It depends how good is the model created in the CAD program. Now, there are other possibilities, for example, with the direct interfaces from RFEM to Tekla structures, or to Revit, or from Revit to RFEM. Let's show that. I turn to Revit, and if you create a physical model and in parallel an analytical model, you can also create supports and so on. And if you export such a model, you don't need to modify so much as I showed for the IFC model. Let's do that. We turn to RFEM, the RFEM table here, or dialog. There are conversion tables. You can also add different cross sections that need to be transferred, and then you can go to the export. You can select if the set direction is upwards or downwards. You can override the existing structure and so on. You can transfer the analytical model, physical model. You can do structural settings. You can transfer nodal and line supports and so on. I need to go back to RFEM and go to an empty model. It's an empty model. So, and now I start the transfer. Start, okay. Now that takes only some seconds. We go back to RFEM. And now you can see the transferred model. That looks quite better. We can turn to the wireframe model. All members are connected and so on. So let's calculate the model. I create a static analysis setting and calculate the load case, self-weight in that case. So the same workflow is in Tekla. The input is analogous. And as I already said, as better the model is prepared in the CAD program, as less additional work in RFEM is necessary. Okay, so I close that model. And I save this model. And we turn to the next question. The next question is, can I transfer a support load to any location in the target model without defining a node here? Yeah, that is possible. I would like to show you how to do that. I open also the floor slab, or I show both windows. Okay. We would like to transfer the support reactions to this floor slab. Let me switch off the user-defined coordinate system from the CAD model. You can see the steel structure is in the positive Y direction and the floor slab is in the negative Y direction. Yeah, and for the feature that I would like to show you, that doesn't matter. Let me rotate it a little bit. Yeah, we would like to transfer those 4 support reactions on any place of the floor slab. How to do that? We turn left above to insert, or at first I must we would like to show the numbering of the nodes. Okay, that's quite important. And I add also dimensions in the structure. Okay. So 5.8 meters in X direction and in Y direction 4.4 meters. So then we turn to the floor slab, then insert loads, 3 concentrated loads. The feature that I show you will be released in a short time for 3 line loads as well. I showed it for the 3 concentrated loads. I have to select import support reaction, and with this button I define the location of the loads. So let me select the point. For example, this point. Okay, and I have to define the node number or select the node number. That's the model name. IFC import. It must be in the same folder as the target model. Yeah. So then here you can select the load case here and the node here. That's node 18. Okay. In set direction. Okay. That's all for one support reaction. We need to copy that load, 5.8 meters in X direction. Copy. Okay. So, and then both loads in Y direction, 0 and minus 4.4. Okay. So now we have to assign the nodes, node number 10. Okay, node number 10. This one, node number 14. Okay, and for this one, node number 12. So then we need to calculate the load case, and the loads were transferred from the original model to the target model. Takes some seconds. Okay, so now let's compare the values. 5.68, 5.68, 6.323, and so on. It matches for all the 4 loads. Yeah, okay, that's also a little bit complex, but you are absolutely free on the locations in the target models or model. And the other feature that I already showed in a previous webinar is insert load wizard, import support reactions, load wizard. And with this dialog, you can transfer all supported nodes to the target model. At the moment, you have to select the single nodes in the target model, but we will implement a feature that you don't need to select any single node. The program should detect where the different supported nodes are, or the loads from that nodes are transferred into the target model. And that's our future plan to improve that feature. Okay, then we turn to the next question. I open the next model. And the next question is, are offset moments that occur when notching cross-sections considered in the design? Yeah, the answer is yes. I would like to show you that on an example. You can see 2 single-span beams. I turn to the solid model, and you can see notches here at the start and the end point. For the upper model, I defined that with a design property, and for this one, I created different cross sections. Cross section with a height of 140 millimeters, and on this place 240 millimeters, and that's the notch, and the axis of the member is higher than this one without notch. So, and you can see the internal forces are the same in both models, at least the normal forces. So, but for the MY internal forces, you can see where's an offset moment in this model, but not in the upper model. But I created design properties for this member, and later it will be considered in the design, this offset moment. So I show you the properties of the member with a double click. Go to the design types, and you can see where our local section reductions are created. So at the start, we have such a notch with a length of 20 centimeters and a depth of 100 millimeters. And the same at the end of the member. Okay. And I simulated the same notch with this model. Those are rigid members. Okay, and let's go to the design, to the timber design. So I go to the design ratio by member. You can see all the design ratios are the same in both models. 0.22, 0.22, and at the end and at the start 0.96. Okay, and that's the member number 1. That's the member 1 in the table. I double click on that line, and you can see in the design checks, you calculation of additional bending moment is considered. The normal force with the eccentricity because of the notch, and you can see that it is considered. That's the answer of the question. Yes, the offset moments were considered in the design. Okay, then we turn to the next model and the next question. The next question is, how do I consider the Qfat value for level 2 fatigue design for concrete components? That's a simple model, a 2-field beam of concrete, different load cases, the self-weight load case, fixed load, storage room left and right, and forklifts load on different places. We simulated such a moved load. So, and let's turn to the load case and combinations. So where we created result combinations, then the load cases, and for the forklifts, I selected in the additional settings, consider as fatigue load for all forklifts load and not for the others. So, and the fatigue effect is generated in the actions as soon as a load case has been given the option. You can see the fatigue action. So then let's turn to the design situations. We have got one design situation, ultimate limit state, FAT, fatigue. Okay, and the result combination is selected. At the moment, it only works via result combinations. You can see the forklifts load case 10, or to load case 15. And if we click on the info button, you can see the fatigue loads are considered 1 time. Okay, that's all to this question. The next question is, what is the purpose of the artificial intelligent assistant MIA in the program interfaces of RFEM and RSTAB? You can see on the right side at the bottom, the MIA. If I click on it, I can select, or I can enter a question here. The reason is the 24/7 help with the program for you, that you can ask MIA anytime, in the evening, in the earlier morning, or at the weekend, and so on. That you get help anytime. You can move the MIA in any direction or to another screen. You can also switch off the enter dialog here with that button. Let's enter a question here, a typical question. What can I do if RFEM reports an instability in the structure during the calculation? And when you enter such a question, it will be connected to the website, and MIA search on the Dlubal website, in the FAQs, or in the product features, or the knowledge base library for an answer. And gives you the answer, for example, for this question. And you can do that, as I already mentioned, anytime. Okay, that should be all for this question. I turn to the last question for today. And the question is, can timber panel walls be created in RFEM? And that's an often asked question. And let me switch off the Mia. Yeah, and that's a quite new feature. And then the answer is now yes, we can create timber panel walls. I would like to show you how to do that. I create a new rectangular surface and I have to create a new thickness. And the new thickness type is beam panel. And with that beam panel, you can create a timber panel wall, for example. You can see that in the preview. Let's fill out the different dialogues. We have to select the material. I turn to the library, timber, then an OSB sheet with a thickness of 18 to 25 millimeters. My sheet should have got a depth or thickness of 19 millimeters. Okay, but we have to select another material model, an orthotropic linear elastic material model. Okay, let's enter the thickness, 19 millimeters. For the sheeting on the back side, the same sheet, an OSB sheet with a thickness of 19 millimeters. Then the framing members, the horizontal members and the vertical members at the outside here. Section, we have to define a section, a massive section with, of course, another material, not OSB, but timber and solid timber. I choose Eurocode and then softwood C24. Okay, and I have to enter the parameters, 60 millimeters and a height of 180 millimeters. Okay, so then you have to select the connection type, nail, staple, or user-defined. Now, in my example, I choose nail. Then I enter the connector dimension, 6 millimeters, and a spacing of 100 millimeters. Okay, so the connector stiffness is calculated automatically. Let's turn to the last dialog here, the inner studs, these ones. I choose the same section, 60 by 180 millimeters. The distribution should be entered center to center or gap or uniform or user defined. I think center to center is the most common entry. I have to select the spacing. A typical spacing of the OSB sheets is 62.5 centimeters. Then also I have to choose the connector type, also nail in that case, 6 millimeters and a spacing of 100 millimeters. Okay, that's all. I have to select the dimensions. For example, 5 meters width and height of 3 meters. And you can see the wall. And with that button right above, you can display the beam panel. And now you can see the submodel. You can see the sheets on the outside. Then the beams with hinges, but it's quite stiff in the direction of the wall. Let's check that. I enter left above here line supports. I select the line. Okay. Then line support, create a new line support in all directions. Okay. And for the upper lines, I select another line support, new line support, only in Y direction. Okay, in Y direction, that the wall doesn't falling down to one side, for example. Okay. Okay, and I select these lines. So then I enter a load, a new nodal load. For example, 10 kilonewton in in X direction. Sorry. Okay. In that node. Okay. And let's calculate our let's check the deformations. 0.4 millimeters. I can see that it's a quite stiff construction. Okay, that should be all for today's questions or the questions that our customers asked the last time. I would like to show you where you can find the recording of this webinar and the models. We uploaded the models there. But before I do that, I would like to go back to the PowerPoint. You have the possibility to book your free online appointment, such as a product demonstration for RFEM, RSTAB, RWind, or any add-on, what you like. Then just contact our sales team with that link here, or you can scan the QR code, or if you would like to get the non-binding offer from our sales team, you can also contact them. So let's turn to the website. Okay, so our website, dlubal.com, with a new design. I hope you like it. And under news and events, and here under events, you find the webinars. So those are the webinars of the next weeks. Next week, the Python IPA. That's quite interesting webinar, I think. Then linear stability analysis. The week after next week, then we introduce the RFEM and Tekla interface. Then the next most frequently asked questions webinar in April, and so on. So let's scroll down to today's webinar. Those are already the planned webinars. That's today's webinar. It's also already in previous webinar because we're at the end of the webinar. I click on it. So, and in the next days, you will get an email with the link that leads directly to that page. Then you will find the recording here. You will find the PowerPoint slides, and you already find the models here. And then you can go through the webinar with the recording and the models. If I went too quickly through the webinar, but with the recording and the models, you can do your own checks or own entries and so on. Okay, that should be all from my side. Thank you for your attention. Thanks to Jürgen for answering the questions. I hope you liked. Yes, you can go to the survey when you leave the webinar. Just note that the worst score is 1 and the best score is 5. You can enter wishes for future webinars, for example. But you can also leave the fields empty. Okay. Good, then have a nice rest of the day. Maybe we meet each other in a future webinar. Would be very fine. Bye-bye.